Yeah, so when we are designing our pipe networks, pipe networks come in different forms. There's when you're doing maybe when you're going to do pressure pipe networks. Pipe networks, that's where you find the water, like this tap water. You can design something with that. Then you can make pipe networks that are for utilities, like network cables. You get it? Then there are pipe networks when you're going to do the stormwater roadworks. So I'm going to do stormwater, but I mean, if you get maybe another project that's not stormwater, you could use the same concept. Great, eh? So with this, we have two aspects of the pipe networks. We have what we call the structures and the pipes. The structures are the things that connect the pipes together. Let's say that we have pipe one, okay? Have maybe another pipe this side, have maybe another pipe this side. Then in the middle, we have a structure. Yeah. So this would be pipe up, and structures. Now the structure can be in a, if it's, because structures are not only at the start, we even have a structure at the end. We have starting structures, we have intermediate structures, and end structures. There are structures that can be used at the end and the start. Now, normally the ones at the start, most of them work also at the end. For example, if you look at things like the headwalls, can work at the start and also at the end. Yeah. So if you look at these designs, you need to know the structure that you're going to use in your network. Apart from these other things that we've been doing that just come and then put in the features you have here, it's better first make a catalog of the tools or the things that you're going to use for your network. For example, I'm going to use this number of these pipes, maybe 900 diameter pipes, this thickness, this material. I'll need 600, I'll need 300, I'll need 450. You get it. So you make a catalog of those pipes. Then the structures also, you make a catalog for them put together. Eh? So we have pipes and structures. So we shall be talking about that more often. And for you to effectively design your network, you need also the profile to be there because you're going to design the pipe network, unlike the road where we have to design first the alignment, then come the profile. Here you design the same network, but it has XY, but also you have to project it to Z to see how it varies with the road. Okay, so um, continue with this. Maybe there's something I didn't show you with the AVAC, you just remembered now. With the alignment, with the assembly. Sometimes you might want to get a special type of feature eh, that is not in your assembly. Put together. Like let's say that you might have a drainage design. The client has given a drainage design, but if you look at the drainage design criteria that the Civil 3D has, there's none that can fit that. Put together. Like for example, let's say just a quick one. Let's say I know there's a drainage design we used sometime and it wasn't part. So let's just do it real quick. Okay, it was under here. This phase. Concrete solid drainage. Okay, I think it's this. Let me check this. So this road was supposed to do, this is the Spear Motors section, and the client wanted this type of drainage, the V drain, with a thickness, but this design is not there in Civil 3D. Okay, so what I did, I think, look, it's under drainage. I think it's this. I don't know. Did I put the whatever here? I designed this, but making a different type of assembly to mimic what we wanted. Eh? Let me first show you this one. It's appeared now. Yes. I think it was here. I got the corridor from. Is my, where has it disappeared to? Okay, it's here. Here I was just putting the two together, the surface and the corridor. And you can see the design there. We first have it alone. Yeah, this one. And you can see how it adjusts to the prevailing situations. So in that case, how to generate a customized kind of a sub-assembly to attach to your assembly, you get, let's say, this is the design that you're going to use, okay? You get the design with the measurements, the thickness, and all that stuff, okay? Then you come, paste it here. Now, you can get a sub-assembly design from objects. What together? You seem to be not together. Eh? What I'm saying, you need to get the feature that you are going to, with the correct dimensions, the feature that you're going to transform into the sub-assembly with the correct dimensions and the orientation. Now, you put it side to where you're going to put your whatever, your assembly. Then you come under home, there's create design. Now, from there, where you see the pipe networks, there's a tool that has create subassembly from polyline. That's why actually I remembered when I came to this. So there's this create subassembly from polyline. So you already have a polyline that you're going to move, make a subassembly from. So this is the top of the drainage. This is the drainage. This is just CRS. So before we actually even continue, this is what we call origin, where these features originate from, just like the way I put in this one, and then automatically it acts onto this code. So this code is its origin. So when I get to a situation like this, I need to make sure that I get a common origin for these two, because these are two different things out together. And why I cannot, because you may say, why don't I just join it to be together? Because now when it comes to my computation of materials, when I'm trying to compute materials, because after this, I'm going to show you how to compute the materials. When I'm going to compute materials, this is of a different material than this. So if I'm computing my concrete materials, it will be taken as concrete, even if it's not concrete. Yeah. So what I will do, I'll come to this. Hey, no, I want to first make a joint origin. So I'm going to make this origin. So this is going to be the origin for the top one. Let me also introduce another node. You see, there's no node there for the bottom one. So I want to introduce another node. Then I'll make it the origin for the bottom. So I'll come from polyline, then I select the polyline. So to ask me how to name it, I can say maybe DRG for drainage. I make sure that I have my all codes on. That's the mid ordinate. This mid ordinate normally works for curve whatever features. The smaller the value, the smoother the curve will be. Yeah. So I can erase entries, it will erase the polyline. So I'll just do that. And you can see that it has created for me an assembly. But if I click on it, where the thing is, that blue thing is, that's where the origin is. So I have to come and modify the origin, and I put it where I want it to be originating from. Are we together? Or, cut now, how do I join it here? It didn't change because I only clicked the first one. Yes. So how do I want to join it here? Let's say that, for example, I want this to be down here. So my target anchor point is going to be this one. Oh, I join it down here. Let me just join it down here. Then we shall just put a cover for the walkway. I'm going to join it down here. So my target anchor point is going to be this one altogether. So since that's my target anchor point, so I need to modify the origin to this one. Now my bottom, its origin will be this one altogether. So what I will do, I will now come again and quit that. Then I click on that. So this one I won't call it DRG CRS. Okay. There's existing entities here. So when I click on it, its origin is there. I just modify it to this one here. Are we together? And I can even click on it and add a shape. Now, when you add a shape, that's what happens. It adds the shape. Now, when you add a shape, you're adding, like, it's going to now be able to compute volume for that shape. Otherwise, they're just lines. If you look at all these ones, they are not just shapes. They're not just lines. You find that there's a line, but also there's a shape in the middle. Now that shape is, for example, if I click on this one, is coded. The reason that's why it's appearing like that because it's coded as a material. You get? So when it comes to computing materials, you'll be able to say, okay, I need concrete. What the volume of concrete I want to use? Volume of asphalt I will use. Makes sense. So if you come to the sub-assembly properties, under construction, I think under codes, you see that these are, we have all codes are there. edge of the travelway, crown, and then it will put for you. Now you see we have not computed. The moment you see this cut track, that's a material thing. We have not computed these pay items yet. So it has all these are different codes. When you come to the shapes, you can see these pave 1, pave 2, pave 3, sub base, curb, sidewalk. So if I give it in the material of a curb, let me show you. So if I want to give this a material, because now the material it's having is the same as this one. So I want to click on it, add the code. I click in the middle, then I put curb. So it has now given it the material of a curb. We're together. We are together. Yeah. So you can click on that, then add to assembly. So now I'm ready. I just come and add it onto here. It will move it to that. But here it is very low. I think I should put it here. But here it will be again. Just leave it. So if you have a cover, you also put the cover there. So here, you click on that. No. Click on that, add to a sub-assembly. So since it already has the code, I just need to make sure that I put on the code I want it to be at. Put together. So that's how we keep on adding things on your assembly. So if they're not there, don't panic, just design your own and just add it there. Yeah, I think this can be helpful. Actually, it's very helpful because most cases you're going to find that the things that you want, you're not going to find them this side. You have to design that structure maybe. Can even design it from AutoCAD, normal AutoCAD, and do this side. Yeah. But make sure that you design it with the dimensions that you want. Because if you after making it like this, you cannot modify that. Since you see with this one, you have the capacity or the capabilities to modify the origin, the dimensions. When we come to this one, you see, you have almost little whatever. You see, this is the drainage assembly. See, these ones have the capability to modify these parameters. You see this, the sidewalk, the whatever. But if I come to this one of mine, there's nothing. Just come with is correct. Yeah, that's the only downside of it. Hmm? Yeah, you can design with the polyline, but make sure that it's with the correct dimensions. Even the slopes, the whatever, you make sure that all of them are checked before you bring them inside. Yeah, so it can be very helpful. I had forgotten that, sorry. So now since I've added it here, I know it has updated also in this one. So for the pipe networks, I would still come down to the same tool. That's why I remembered. Now we have what we call set pipe network catalog. Now different different countries use different pipe catalogs. Now in Uganda, for example, I think we're adopting the metric one that is there, but also there are some things which are there that we don't need, and also there's some things which we need and are not there in the pipes. But now some companies actually have also come up to design their own catalogs. Now I know for a fact that Gentex has a pipe catalog that you can download from their website to use in Civil 3D. Pipe catalog means that they have designed for you the pipe dimensions that you can use in your design. For example, they will put like say PVC, this material, this, so this for you. So just come and say, I want to use this pipe, this stretch. All together. Yeah. So here we have, you can come and check whatever that you want to use. We have the metric pipe catalog, then with the structures catalog. I remember I explained to you the pipes and the structures. Yeah. Then also, if you want to make a catalog that has all the pipes, you can come and create a full parts list. Now, what this one will do, it will look at the catalog that you have chosen, then generate a catalog that has all those pipes. Now, you click on this when you have time, because it can take 30 minutes. Like to process. These are very many pipes. So it depends on the strength of your computer, of course, but it can take a whole lot of time. So let's now get prepared to start our pipe network. So the first thing is we are going to go and select or choose our catalog that we're going to use. How do we do that? When I come to the tool space bar, there are things here that we've been, actually most of the things that we've been going through are all here if you look through. You have now pipe networks, and pipe networks you find networks, but you don't have any networks yet. You don't have any interference checks. Now we want to set our pipe networks. Whenever you're going to do anything to do with settings, to set something, that's going to be under the settings tab. Now under the settings tab, if I come to I look for pipe networks, now we have you see pipe, now this is the pressure networks I was talking about. The pressure networks, actually even their pipes are smaller. So we have the pipes, you can see the pipe styles, some of the ones that are there, the structure style, but I'm interested in the pipe network. So you have a parts list. Now in the parts list, it's like you have a catalog having all the pipes that are there. Okay, so you create what we call a parts list. Now, a parts list, you list down the pipes that you're going to use. All together. You say, I want to use this pipe, this dimensions, this pipe, this dimensions, this pipe, this dimensions. Then I'll use the structures, this structure, this dimension, this structure, this dimensions, like this. Because you don't want to consider the whole of it because it's too big. Put together. So that's why we have parts catalog, but it's different from the parts list. So under the parts list, we have some default ones. We have this sanitary sewer. So if I come to edit, you can see that there are already some things there. So I could maybe first try to say, maybe let me create my own. And you see how to create your own. You can come, create a parts list. You can come pass into information and give it a name. I will call it maybe trial parts list. Okay. Then I come to the pipes. Now, which pipes do you want to use? All right, together. The letters are small. I increase the resolution. That's better, I guess. This is better. So the parts list, I could come. Now I want to start now putting in the parts that I'm going to use. I right click, then I come to add the part family. Add the part family. Now it depends on which pipes I'm going to use. Now there's the concrete. They will show you here a picture what that pipe is all about. Here are the circular pipes, egg-shaped pipes, elliptical pipes, and rectangular pipes. You have the concrete pipe SI, the ductile iron, the PVC, the corrugated pipes, HDPE, they're all there. Depends on the pipe that you're going to use. Say, let's say maybe I'm going to use PVC, maybe, and also concrete. These are normal culvert pipes, the concrete pipes. Egg-shaped pipes, these are very rare. Elliptical pipes, maybe also the rectangular box culverts. These are like the crossing culverts also. So after choosing my family, I say, okay, now that's the part family. Okay? So they are here, the pipes that I've chosen. Now I just go ahead to choose the dimensions of each pipe that I'm going to use. So for example, if I come to the concrete pipe SI, I come, right click, add the part size. Under the part size, you find that there are things that you can change. Why are they in inches? Am I using the imperial system? Hope not. Hope not. Oh, no. I think it's not the one. If I say okay here, I check which system am I using in the pipe catalog metric. If you choose imperial here, it will show you those things in inches and feet. Huh? This is the one. Let me edit the one I was working on. So add the part size. So it will show me the different things. So the wall thickness of the it will put it there. But now most of these things are controlled by the inner diameter. You get it? So the inner diameter, this is a concrete pipe. These are like the culvert pipes. So have, I think these are, the minimum, isn't it 300? That's accepted, I think. 300 is 300, there's 450, there's 600, 900, 1.2, like that. So for example, if I choose 600, you see the wall thickness so automatically changing. Let me choose 450. 450 is here, and you can see it has gone back to 100, the wall thickness. If I choose 900, you can see 175. However, you can also adjust this if you want. You get it? These are like they are standard. Maybe you can say that for me, I'm going to use this one. So you can, I think they go as, I don't know which pipe is 400, 4 meters. I've not seen this one. It's too big. They go as far as that. Let's say it's there. Yeah, this one is very. Yeah, but this one. Yeah, but so maybe. Let me see the whole thickness of 4 meters. 0.5. So. And I think there you put rebars. There's no way. I put like typical rebars in that one. So let me choose the one of 600. All these things are like you can come and edit them. Okay, depends on what you're really interested in. So you can put that. That's like the first part size. So you can add many sizes, by the way. I can say maybe I'm also going to put 300. Also put it there. And maybe I put 450. But never make a mistake. If you, for example, you made a mistake and chose 450 and maybe your target was 900 and you come and edit, you can edit this whole thickness to 900, but it will not Here it has changed. But in most cases, it does not change the name. So you need to be careful at that. That sometimes you may change and then it doesn't change the name. So you just delete and add. Perfect. Just delete and add another one. You can add another one, maybe at depending on how many sizes that you're going to really use. Then the PVC still is the same thing. You come. Now the PVCs are normally thinner than the whatever. So you can come to the inner pipe diameter, let's say 400, let's say, okay, 300. You can see the thicknesses are little bit there. Then the box culverts still are the part size. Now in here, you have, instead of having the inner diameter, here you don't have a diameter. You have the height, yeah. So you can come and edit these things. You get. Or you could even just come and right click. Wait. Add the part size. Yeah. Here it will show you the size, the dimension that you're looking at. Depending on the height that you choose, it will give you the dimensions here, depending on what you want to choose. Then you come to the structures. Now, by default, it will give you a null structure. This is a structure. It's in case you have forgotten to make structures, it will give you a structure that to start with. If I right click on this, add a part family, the families are there, and you can see each of them. These are inlet outlets. I think I explained this. The ones that can be used for the inlet, also for the outlet. These are rectangular head walls. Those type of head walls, you have junction. Now, these are junction structures with frames. All there, depends on the type that you want to use. Now, we also have the ones without frames. How together? And this one, let me say inlets. Let me choose at least one rectangular head wall with structure. I choose which one. Depends on really what you want to use. Maybe I also choose that one. When I come here and right click and then add the part size, just like they would have been added on the other side. Now together. So here you can have a summary of what you've done, number of pipes, number of structures. Now in here, you have now zeroed down your search. You're not going to like search the whole pipe, just come and choose the specific types that you're going to use. Then let's check, let's look at they have already what they have designed for you. You have the standard sewer. You get there, they have created for you some of the pipes that are used, the PVC, and they have put for you the sizes. And this same thing for the structures. Then the storm sewer, the pipes, concrete pipes, SI. Now these are not PVC. The structures are also there. And then there are sometimes when people use the perforated pipes. The perforated pipes. Wait. I don't know how you call it. I know you know them. Maybe you call them a different way. You've seen pipes that are cut. They're not like PVC pipes, but then they segment it. Let's see if I have some here. I know. I don't know if this is the name. Yeah, this type of pipes. But here they put holes, but most cases they cut it. You've seen them, eh? Here they are put holes, but this type of pipes. Now these ones we use them normally when you want to, for example, in road construction, that there are sections where, okay, Kubid roundabout. Yeah, now that junction. That place has an underground river. There's a river down there. A real river. Yeah. The underground rivers. It's not that like water is like flowing like this, but I mean like it moves. Where can they put his church? Actually, he even has a well inside there. He claims that that water is holy water. Yeah, he has a well there. Just praise the living. Yeah, and if you remember that section used to fail a lot. Yeah, it fails a lot, it floods a lot. Basically, it goes down there, this underground whatever water. So yeah, like even though you do the top part very well, the other side the water is going to come and yeah. So what we did, you excavate, but again you cannot excavate more up to the bottom, whatever you have to do, excavate. So some cases you put rock fill. Now that rock fill, if it's not sufficient, water is going to be above it. So what you do, you drain channels, then you put this kind of pipes. Now they take away the water, but they don't take it away. It's not directional. It takes it away in the direction, but also it also leaks out. You get it? So in that way, it that you put the rocks, then you put cement stabilization. Stabilization now works like a seal because the whole point of cement stabilization, you don't want the water to come up. Eh? So like it keeps the water down. So you keeping it down. If you don't plan for it, how it's going to escape, it's going to spoil your things up. So you put pipes, kind of divert that water. So those pipes that we use in that situation, they're called these perforated pipes. And actually, even I think I've seen these guys who do soak pits use these kind of pipes. Yeah. So these ones you see that they're on the other side. So if you want to use that kind of pipe, you have to use customized catalog for that. Any question? Okay, so if there is no question, that's it. With this, there's interference styles. If you have now here, if you have a complicated network, now because of course this network that we're going to do is really like not that complicated, but in times when you have it happens so much when you have a complicated network. Now let's say that we're doing this not for storm water, we're doing for a typical maybe network. There are going to be a lot of networks that are crisscrossing, whatever. So you need to look for interference in some scenarios. So after doing all these things, setting your pipe catalog, the parts list, setting everything, now the next part is to start with your designing. Now, at this stage of the design, you need to have an input from the hydrologist. You cannot continue with this stage if you don't have an input from the hydrologist. The hydrologist is going to show you or plan for you how you're going to move the water. Great. The hydrologist will also, because hydrology has two parts, I think you remember that the whatever in the civil class. You have hydrology and hydraulics. Which one deals with the pipe dimensions. That's the hydraulics bit of it. I think that's the easiest, not so? Hmm? But it should be a boring thing, like it bores people. I don't know why, but people really get bored with it, whatever. But in here, you need to have done the studies for hydrology and hydraulics. Hydrology will show you how you're going to collect the water. Like most of the water, for example, they can tell you that maybe this area is going to be like a sink pond, like it's going to be an area where water is going to collect from. So how are you going to move it from there to the next step? So they will show you areas where you have to put the drainage. Then after, they also show you the sizes they want for those drainages. Actually, hydrologist is even the one that most cases comes out with this dimension of these drainages. So you just have to implement. They have to do their studies to show you, to simulate. For example, if it rains, when this thing fill up, depending on the volume of water that we have. Because ideally, you need to have it maximum half. That is the literature, but sometimes we copy things from whatever they do to here, and then we forget that we have dust, we have silt. We have people who put the rubbish in these things. We can actually design a drainage that is sufficient, but because of our behavior, the thing blocks.
But
Yeah.
now, what do they usually know? Like, I see the most roads they're starting to adapt to the covered.
Yeah.
On the green.
One, the covered drainage has advantages and disadvantages. One of the advantages is it's clean. Like you don't have to, you don't you don't put in, okay, there's little space for you to put in the rubbish. You get it? Then it also saves on space. Because just imagine that you have from this. Let's just imagine that you have this, you have a walkway, then you have an open drainage side. Like this is going to be a lot of space. Instead of having the open drainage on its own, whatever, just put the drainage down, and then on top of the drainage, you utilize that space for a walkway. So it also saves on compensation that you don't have to do a bigger width for your road. Then it's also a health hazard. Like if you leave it open like this, it might fall in. Like it has its own whatever. But also now the downfall of it, that cleaning it becomes very hectic. You get, if in case it blocks, you may end up just disorganizing the whole walkway, just clean it. Are we together? That's
Such point special change.
yes. Now I've seen this one that the Old Pitbull Road. Now that one, those Chinese, they are putting culverts. They are not, because this is, it's not a huge drain. They are putting culverts. Now that's very complicated even to like work out if that thing blocks.
And there's so many social one.
Yeah.
I've seen so many ways. But for maybe someone can fix it, provided they have one instance and it has 20 meters. Impossible. Yeah.
I think you find the snake there. Okay, the best thing, there's one we put at Spear Motors. I don't know if you're coming from up, going down to Spear Motors. There's a bond there. We put a covered drainage. Yeah. Yuasa, okay, yeah, Yuasa. Yeah, going down. There's a covered drainage we put, but this covered drainage is like this, but we put covers that are removable. Now that's better for inspection. Just remove those covers, then put the covers back. then it can work as a walkway. But still, if someone has given you're a designer, someone has given you their input, just do what they have done. Yeah.
So sitting on phone, use the project design road.
Mm.
But the road is so narrow.
Mm.
Is it possible to have a drainage under the road? Or it still has to be a walkway?
Under the road.
Yeah.
It's okay to have a drainage under the road.
You got have it.
Yes. Actually, the drainage that go under the road. But it is expensive to put there. First of all, the reinforcement that you're going to put on that drainage is going to be too much. Here, I don't have to do a lot of reinforcement on the drainage because really people are passing there. And then you find borders passing on top of this thing, not knowing that that thing was not made for that. Yeah. But if you're going to put a drainage under the road, put it there, but just know that you're going to put a lot of money to reinforce that thing. Otherwise, it's going to like fall in. Even the method of construction itself is complicated. Because if you have a drainage under the road, the compaction, how are you going to compact? Because you may compact, then you end up breaking the drainage. Unless maybe you could use it, if you have little space, I don't know, you could introduce a median, then in median you use it as a drain. I think there are sections of the northern bypass where you will find a drainage in the middle of the.
That's only enough. Best space. Not only from this space now. The situation I'll be spreading that I've seen this somebody saying for the road, like, always say, residential. But they had to put the drainage and they didn't have enough space to put the drainage on that side. So when I was seeing them like doing all that stuff, the only thing that would come to mind was the only place where like where to put that drainage is
below
the road, because it is just actually the road only has space for basically one lane. Okay, like 1.5 lanes, I think. Yeah, like 1.5. You can't have 2 lanes.
Then you could have an open gutter. Depends on the volume of water. You could have an open gutter.
Another problem was coming from the residences. That was another problem of that road. So because it had so many, because okay, I talked to one of the engineers who was trying to design that mistake. Now what I can from homes is also too much, because it's like if you notice wherever there's a home and where the water gets out, you have a garden, a big garden. So he was like, so me, I was seeing them and I was like, oh. So
That's a complicated.
Because they have, it's a slope also, so it's like what the hills. They need to have a drainage system one side. And it can't be on both sides. It has to be one
side.
You think some crossing currents.
You could have it that, or even you might have it. But again, I don't recommend to have water just cross over the road.
Then
yeah, it messes up the road.
The only thing that can maybe resurface water.
Maybe one side you can have an open gutter, because an open gutter is easy that you can actually pass cars on top.
Yeah, you are like don't too much, so you're like that's. If you put a gutter over, you're like just like 4 or 5 rainy seasons. And to start eating into the road, like the water starts pouring in the road. And that's the reason where the residents with the course card and then go here,
then yeah, that could also work.
I don't know what
there's a whatever I'm seeing, I think that is the Kulambiro Ring Road. I don't know if you've passed there before. These guys have an open gutter, but they have an open gutter. They kind of they designed it very well. Like they have an open gutter. Then below the open gutter, they have culverts, but those culverts are deep. So yeah, they're not near the surface. So they move the water, they want it to collect, then they push it deep. Like they push it deep. Now, if the drainage is very deep, even the reinforcement is not so much.
Ring road.
Yeah, ring road. Kulambiro Ring Road. Kisasi is that ring road.
They have the pavement.
What do you mean?
They have a pavement.
Yeah, they have a pavement.
But the pavement on the upper side, about
Actually, that thing has two open gutters on both sides. They have two open gutters, but then they have sections where they push the water down. They keep on pushing the water down.
just goes down.
Yeah, but those things are deep. Like even when you look like it's like deep, I don't know how many meters they have deep. Maybe like 1.5 or 1. I think it's deep. So depends, but normally you need an input from the hydrologist. Hydrologists are engineers also.
Yeah.
Yeah. So maybe like some others or whatever profession.
That's not in yeah, constructing permanent when it comes. The social houses, finding road is something like
Very narrow, right?
and the road of where against it. 900 on the other side. Then where is it? This house?
They put a process.
Process change the 900.
Then they continue.
Down to
That could also work actually.
this is small. You see, so this way is so funny because on this other end of the road, most of the lands are unoccupied. All the residents are on the road. One line down here. So it was like, that's not make sense to put the vehicles
On the other side,
on the all the hotels.
this side.
And all the because it's generally the general topography of that place. The water from the other side doesn't come to the road. So he was like, doesn't help. You can see all the guys, all the water being done, all these trenches on the road that are being done by water coming from
the residents.
And the resolutions this side. So he was like, doesn't make sense.
Then you have maybe to like put it deep or something.
So I sat there, so I looked at what they were doing and I was like, I want you, why don't if I think about that?
But still,
the thing is my problem. I think they will have maybe if we can just get the exact spot where that water comes from, try to create a drain, and they can make an underground kind of like getting the direct on the one side.
On one side or whatever.
Rather than leaving it now just by its own.
And actually, you might also find out that drainage is very complicated. Even with the flooding situation that we have, you might see that you only want to solve that problem, but solving that problem may not be solved from there. Maybe solved from, and when you look at the area in the holistic perspective, you may find that yes, these homes are having a lot of water, but the water that is actually coming there is not from those homes.
From somewhere else.
Yeah, it's from somewhere else. So if you curb it from where it comes from, you will find that you have to do this one.
Also, the homes get to go somewhere else.
Yes.
You have to find a solution.
Yeah.
It's like a residential house.
I don't think it's a residential. Yeah. That's what I'm thinking, that I don't think it's like that. It's just like the way that's
where it is.
Yeah. Just like that area that electoral commission, that place we used to flood. Actually, even now it still floods so much. And then there's a time when they were trying to devise means on how to actually come by the whatever. And then they were saying that put bigger drainage or whatever. But then thinking about it, not the water that floods there, it doesn't come from there.
Comes from up on the hills.
Yeah. Like you need to curb that water from where it comes from. Even though it makes things big, but if you don't solve their problem, it's going to still come and spoil. Yeah. Even Lugogo. Now Lugogo, that
it's because it comes in order.
Yeah. Like you need to curb it. You need to kind of divert it from where it comes from. That by the time it gets here, it's not so much.
So it's not the drainage is not there, and the drainage is there.
It's big.
It's big. I don't think we can now they can go. I don't think they can go because I think let's just have to check that whole
big
trench just forward and still the place floods.
So you find out that maybe their problem, you need to look at where is water coming from. Then you kind of curb it, and you may find that you have the simple whatever.
It's coming from drainage is there, because of the cells, they're not look to the doors. Actually,
There are many things.
now like, okay, that's right. There's so much soil that comes to farm.
Yeah, a lot.
So I think the drainage are broke somewhere, you know, that is.
And we don't maintain. We don't do. But when we are studying, they keep on telling us open inspection, whatever. But doesn't stop in books.
No, they say, the British left for you, for everyone, they do it at the same time, we are still working. Hours. Yeah, that's why in the railway, they just have to tell you the railway
Was here. You don't see anything.
You won't see anything with it.
So the hydrologist will give you the areas on where he's inspecting and having the water move. So you like have to design that part. Actually, if you are lucky enough, the hydrologist will design for you. The draining network just have to include it in your design. But as a CAD specialist, you also need to know how to put it there. And good enough, if you have if you've done, if you are a civil engineer, maybe someone who has done hydrology modeling before, you can actually even do this part for yourself. It's now like there's under GIS. I don't know if you guys have used GIS before. There's a part of hydrology modeling. You can model because here you need a topo. You need a topo, then you do the hydrology modeling for the whole entire area, then it will give you areas that are what? Let me just try to show you the tool. This is where now CAD can actually CAD and this software, they're almost hand in hand. Like you will use them most times. You do something this side, then you move it to the other side. Under geoprocessing, there's a tool called Archhydro. This one, Hydro tools, and you have all these kind of things that you can use. You have watershed delineation. They have different methods that you can use to delineate your water. Terrain processing. Now you get like a digital elevation model is like the topo data that you get, then you feed it into the software, then it will analyze for you, then get for you areas that are prone or collect out of water. You get it? So those areas that collect a lot of water, you kind of plan. Now you plan how to get the water from that area way forward. Get it? But if you're just designing, probably if this you can do if someone gives you like a simple project and you really maybe you don't want to incur the cost of putting in hydrologist, you get. But if it's a serious project, a big serious project, there will be hydrologists, so you don't really have to suffer with this. Like there will be someone dedicated to this type of work, but also you need to know what happens in their field. Yeah. So let's say that they have identified for us the areas that are where we have to move the water from. Let's just assume, because down here, I think I have a river down here. This side, there's a river. This is the lower side. I think if you remember, we had put what? If I click on the surface and we use a water drop, remember that? We use hope I will give it a color like blue. Click OK. This 3D polyline. Click OK. So let me say around which energy. This is 150, 1 plus 150. 1 plus 150. think around here. So if maybe I want to put on this side and see how the water is moving. You see that? Now from here, see how it moves. So most of the water is actually going this side. If I come and analyze here, looks like all this water somehow gets down this side. Let's see. Yeah, perfect. You see now, in this case, my target area is, I need to somehow move all this water up to where it gets to this point. So from here, you can see it goes directly to the river. Would first see if I need some pipe culverts on this side. And see, I think there should be somewhere crossing somewhere there. So depending on your analysis, here we're just really doing some basic analysis stuff. So here, I could even have two of them. Two on this side, another on this side. Then somehow I divert this water down here, then this one I divert it this side. Or I can move the water up to a certain extent, then I cross it to this side. Depends on really how I want the work to be done. Switch off this layer. Let me switch it on back again. So I'm going to draw a drainage coming from 1 plus 150 towards the river. So where do you think we go to start doing the pipe network? Okay. Where do you think we go to do the pipe networks? Start doing the pipe networks. There's a tool here after assembly. Where's pipe networks? Now these pipe network creation tools have pipe network from objects. If you have already lines, I'm making pipe networks. Now these ones are pressure pipe networks. I want to do this one, but also the same method can be used for the pipe networks, the pressure ones. So I'll do for that one. It will ask me the name, I can call it design pipe network. Now you see the parts list, this is where you have to select the parts list you want to choose to have or whatever. So let me just do the storm sewer because mine I didn't really detail it that much. Just do the storm sewer. Now you need to have the surface that you're going to use for designing the alignment. Now you ask why you need the alignment. Because these things, as I'm placing them, they need to be referenced to the alignment. At what chain this is put at. Good. That if you extracting the setting out data, the surveyor can see and such a chainage, I have this. This chainage, I have this. Then you have the structure label style. How do you want to label them? You have the basic data connected with the pipes, whatever, blah, blah. They're there. Name only, if you want to name them by name only, this you also have plan length and description slow. Okay. So these are just really the styles for naming the pipes and structures. If I go to edit, I expect similar things. So here, you just name it as structure 1, structure 2, you get. If I use this and I go here, you see that it will name it by this information, the structure, the station, the rim elevation, sump depth, invert level, in and out. If you want to label it that way, I mean, there's no No reason as why you shouldn't. So after selecting all those things, then I just say, okay. Now it brings for me a tool that I can use now to draw my pipes. One, I need to, this is the first thing, to select the pipe network properties, the surface which we have already done. These four things, we've covered them already. This is choosing the alignment which we have done. Here is to select the parts list. Now here it's to select the real pipe that you're going to use for work. Together. So the first thing maybe I'm going to use first the head wall, depending on what you're going to use first. Head wall or what, depends. I'm going to use the head wall. First, which dimension did I use? Let me use this one. Then what pipes am I going to use? Are we together? So I want to use the pipe. Let me use 900. Okay. So here you're going to do what? Insert a structure. You're going to use these are draw pipes and structures. This is the direction of the drawing. Are you going to draw coming from up to down or down from up? You get it? So here this symbol means I'm drawing from up to down. If it's the other way around, I click it and directs me up. So I need to insert a structure. Let me insert my structure around here. Sorry. I'm going to put my structure. This is what this is the walkway, end of the walkway. Because I think this is the capstone, then the walkway. Depends. You could even put the thing below. Right? Because you don't want to excavate whatever, so you put it below. Depends. Maybe let's say I put it here. That's the head wall. Has given me some of the data. But now the next one, I'm not going to use the head wall. I'm going to use cylindrical junction structure. This is quite big. Let me use this one. Concentric structure. So this is going to be like a manhole, eh? Depends on how you want it. There are rectangular ones, which are like the catch pits. Also, there are circular ones. Let's say we choose rectangular one. And this is 1.5 by 750. Unless the diameter you have is that. If we check this one. Okay. Yeah, this one has a cut of 100 to the floor. Let me just use this one. So next one, I could maybe just go ahead and place these things where they're supposed to be placed. Let's say that's it. So really, I'm just putting, but you get the concept. Even these pipes are making them longer, but I mean, you cannot have a pipe that's maybe 100 meters. You get it? Yeah. So it's something that really you need to give time when you. This thing is freezing. I think the drawing is heavy. And maybe from here. Then the last one, I want to have the head wall for my water down here. Yeah. When I do that, I'll have my structures, structure one, and that's how I'm moving the water. Each of these pipes have, these are meters. That's why I say these are really so many meters. You cannot have something like this. And normally, whenever you're having a network like this, it is advised that the station where you reach and then increase the size. For example, you may start with 600, or you may start with 450, then you come to 600, then 900, then 120, because volume of water keeps on increasing.
The where, not the where, use that pipe network, referencing it from center.
What do you mean, referencing?
Reference just want to buy the network. So moving from the road.
Along with the road.
Kilometers from the road. Just connecting.
Now there, you could first create a polyline, then create a pipe network from a polyline. You remember, it had that option of creating pipe network from objects. Yeah. But that one, why I didn't use it, because it's like automated. And if I show you the manual way, because if you know how to edit the manual way, then the other way is easy. Yeah. So you could have a center line, then just offset that line, then make it a structure. So with this, you can see these things, but there's nothing really you can do apart from just looking at the levels. Now, I want to show you how we can. Let me just put this a little bit back. Let me first select similar. Select this, select similar. Take them to object viewer. This thing has snapped off. Sure. Let's leave it paint, please. Take them to the object viewer, you'll be able to see the network, how it's moving. These are the catch pits. But you're going to note something here, that this thing is really deep. So we're now going to start to see how we can edit in profile view together. So I could stop that. Then there are many options here for the network. If you see up here, you can come to the pipe properties, check them, can come to this. You can rename parts, apply some rules. You can connect a part, you can disconnect a part, you can swap parts. You can split the network, parts list. Now there's this option of draw parts and profile. Okay, so you can come, select that. Now you can select a profile view like this. And here you can see that you have now a clear view of how things are relating together. Which one? How to put them here. You make sure that you select them in your drawing. Then you come to draw parts and profile. Now you come and click on the profile view. Then it will show you. Now you can start adjusting.
Yeah, I get it, but I this if you remember, I used another section, so I can quality. Saying that something is that they have been. I just read it very information and fitting first week's program. I did it, was supposed to cancel it. Yeah, I remember. As I did it. But for me, I thought of great time to create my own. But even I don't know how I forgot. I thought I had done it. I have served it. I don't know how to serve it. So, I tell you,
So with this, you could now adjust, because these ones are really long. Like they're really long. For example, if you see, this is let me see, each box is 1 meter. So this is 1, 2, 3, 4, almost 4 meters deep. It doesn't make any sense. So you can try to adjust this by just clicking on that and putting it up like that. Or you could come to the pipe properties. This is structure properties. Under each properties, you'll be able to see some of the information that talks about it. The reference surface is it's referencing from the edge surface. Okay, you have that. The properties there. Then you have this. Also, it also has its own property. That's the pipe properties. That pipe. Under the properties, you'll be able to see the elevations, the start invert elevation, the end invert elevation. Oh,
you can do it from there.
Yeah, you can edit from here. You can just come and edit. All these things are editable.
Those are ours. Those should think of the matter. Thereby,
They've given you the elevation.
starting from that in computer elevation, equations, the road. So then thereby you have the box slopes of 1.5. You can know if maybe from the door of the road.
I need to go down by
It has
this.
to be like 1 meter.
Yeah.
So you see it there, then
Here, you can just edit from here. Yeah. You can come and edit from there. Or you can just come and use these nodes for moving up and down. See that? Depends on how you want it to really be. The head wall, let me just put it close to the wall. Then this is the slope, and you can even label these parts, by the way. You can label these things in the profile. And label these things, come to annotate. You have label parts. Is pipe network. Now we have, when we come to label, we have with pipe networks, this happens with pipe networks. We have one in plan and profile. Plan is labels, the answer that we have seen. Now the profile, you can also label them here. You can see that here I don't have labels. I can let me just enter network profile. So it has labeled for me the entire thing. Yeah. So you can see that as I'm editing these things, I can see that's actually also adjusting onto this because it had clipped onto this surface. This is the edge surface. I want it to be on the design. In the slopes, you can have the slope. If you have given the slope, you can adjust the slopes. Yeah. So really, this is not so complicated. Can adjust these things. Okay, two comes up there. And this come there. I want it to be moving a little bit from near the road. So I don't know, is this hard?
There's all pretty good much. No, these are just this. There's all pretty good much.
These ones?
Yeah. This one is speaking.
I would suggest that you do it this way.
It's much more accurate than
yeah, it is safer because you handle a section by section.
You have a room to take. Then I think just self-facing.
No, this one is actually this work is expensive. So someone's own.
That's how you do.
You're going to charge a client because the standard rates for doing this it's between 5K. Actually, between if you're going to get a standard like typical code, you're going to get on average, if you're going to do all sets of drawing, on average you have 3K to 5K per kilometer. Yes.
Per kilometer.
Per kilometer.
3K.
Per kilometer.
It's about
3K. But trust me, you will have it's not easy. 2 months. Because you have to design. Now that money includes you designing, then also making the as built. But still, if you have a road of 300 over maybe like 300 kilometers.
That's a project of 20 years now.
Not 20 years.
I don't know. 300 kilometers in 5 years, 6 years.
Yeah.
You can't be only 6 years. How long is it going to take?
I don't think it can take.
You can't take. You're designing from Canberra up to Marat.
First of all,
yeah, yes.
And not everywhere that you're going to put, not everywhere that you're going to put these things.
Yeah.
There are things that are going to be generic. For example, earthworks, whatever, those that you can even give them before. This work is workable. But trust me, here you'll get your money. But you have to wait for it.
If I'm editing that format, let's say for instance, I want to like my top of manual to be like a certain offset from the center line, or not from the center, from the edge of the road. How can I make it?
Now, there's what we call. So, for example, if I get the manhole, this one, because this level is actually center line, level, not the road edge. That's okay. A good question that you brought. When I come to the structures, first of all I know the chain edge at which it's giving me at, and then it will give me the offset from the center line. You see this? That this is a station, and this is the offset from the center line, 13 meters, right of the center line. That's the rim depth. Now, this rim elevation is what I need to adjust. I click on it, come to the structure properties. Under, I need to look for the rim. This is sump. Where's the rim? So the rim, where is it? Insert rim behavior. So automatically it's saying surface adjustment value. It's getting onto the whatever, onto the surface. So in here, just make it false. When I make it false, now it activates my level. Because if it's on, then it will adjust from the surface. Then here, just adjust and adjust here manually. No, the whole point is just have cross sections. Just have cross sections. I'm not sure how to. After this, I'm not sure how to do cross sections. Now, after doing the cross sections, make sure that you have done the cross section on the section that you want. Then you just keep on looking. It's not easy. It's not. If it was easy, everyone would be doing it.
That's why
if it was easy, trust me, everyone would be doing it. But some things that will make you fringe are drainage works. Because with drainage, there's very small room for error. You're going to mess up, and then what is not going to move? Like, what is going to test you? Like, I don't know. But if you make any mistake, I think it will just not work. If your slopes are not doing right, they will not move how they're supposed to move. So, either way, you need to have it. So, let's say that okay, we have done all this. I don't know if there's any more question I have before moving on to the cross sections. Okay. So for the cross sections, how do we do the cross sections? We first do what we call sample lines. Sample lines help us do where we're going to have the cross sections. You get it? First, demarcate where you're going to have the cross sections, because sample lines are connected to the cross section. Whichever you have, where you have a sample line, that's where you have the cross section. Yeah. And these are quite easy. And if you've seen, there's a way we have moved in a bit to one order on how these tools are. And if you've forgotten what comes next is, you can see pipe networks. Now we come to sample line. Then it's only this that is out of place.
Those big doors out there.
Yeah. But anyway, you have sample lines. So I'll come and click on sample line. So it asks me select an alignment or press the enter key to select from the list. So since I have many and I have many other things here, I'll just hit enter. Then I click on my main center and alignment. So it will give me this tool of sample line collection group. So I'm just going to, I can rename it, I can just leave it. Or I can just say sample line collection group design. Here, ask me the sample line style. Really nothing so much here to change in the sample line styles. Then the label styles, how you want them to be labeled. So maybe you can have some kind of work by showing how you want them to be labeled. The sizes, the texts, and all that, which I will show you how to change. Then these are things that to sample. What are you going to sample? Okay. So let me sample things and let me first remove, because you can also sample on the Yeah. Let me first remove these two. I just sample the surface. Then we put them after. I make sure that my update mode is dynamic. If I make it static, I think you know what happens. Yeah, it will not update. Yeah, so then I click on that. So down here, I've done that sample line selection. Then here is now, I want to put my sample lines. So at the station, that one I'll be putting each station. But there's this one by range of stations, because I want to do it for the whole road. Then in here, I will have to do a few changes. For example, from the alignment start, make sure that it's giving you sample line at the alignment start. Then also at the end. Then you have the swath width on the left. The swath width is the distance between, if this is your alignment, how much you want to go this side of the road, and also how much you want to go this side. You get it? So here I have 20 meters, depends on what they have specified. Sometimes they specify. But I think here we can, 15, we can be okay if I put 15. I leave it by 20. Just leave it by 20. No, from the center. If you have your alignment like this, then this is going to be your sample line. So that swath width is this width here. On the left, this is right, this is left. If the alignment is going towards that side. So that's the, on the right, that's the swath width. Then this one on the left. So the one that you see here is that distance. So if you find out that whatever you're doing is in between here, maybe let's say it's in between the green one, then you can reduce. Because if you make it also so big, when you're printing, you have a lot of unnecessary data. You get it? You want your things to be a little bit put together. You don't want to have unnecessary data. I think I'll use 7, but anyway, let me just use 20. And I have 7, but then there's where I have widenings. Remember, we put some widenings, we added another lane that became 14, then plus the structures, the walkway, whatever. Yeah.
Basically, I want to analyze that section 20 meters from the road in the center of the side.
Yeah. Here I have sampling increments. Now that's that increment is from one sample line to the next sample line. And then if you have a road that somehow is curved, let's say that you have a situation like this, you may find that in the curved whatever, you're going to have closer than you get it? It's actually very useful that you have them closer in curves and also at geometry points. So sampling increments, true. Then make sure that the increment relative to absolute station is ticked on. Otherwise, it will just keep on adding 20 meters. If your alignment is not starting from 0, and maybe starting maybe like from 0 plus 5, you just add on the 5. So if it be 25 watt, you get, so they won't be absolute. So make sure that they are there. So here it has a long tangent. These are straight sections. So it's saying to give you 20 meters. Would increase it maybe like 50. 50 meters too much. Just leave it. Then along curves, I can reduce it to 10. Along spirals, those are also curves. I can reduce it to 10. So whenever I have curves, you're going to have more. Yeah. Then additional controls at the start. Make sure it's true. It's going to have you. It's going to create a sample line at the start of the. Yeah. Then also at the end. Then horizontal geometry points. These are geometry points that I've told you. Those are the crucial points. Maybe the start of the curve. You get. Then also at super elevation critical stations. Remember the super elevations that we did? Be able to identify them here. So for example, where it starts to shift like this, so to give you more data for setting up purposes. Hope we're together. Yeah. Then I'll just say, okay, there won't be many. Yeah, but that's it. What I hate about them that they come with their labels are really like weird. So I can click on the label, edit label group. I can decide to label them differently, but let me just reduce this font size, maybe like to 0.5. Don't know. Choose a different font style. Choose Calibri here, Calibri Light. Let me first say okay, and apply. Kind of small now. If you want to add any other information, you can add it there. But I think that's okay. It is far from the line. That's the gap. You see that gap would come. And down here, remove this gap, maybe 0.1. Kind of make it small. I don't know if it has an offset. It has an offset. It has a Y offset. We have it at 0.1 also. Yeah. So by this, you see in the cross sections, we have the closer sample lines. There won't be very many sample lines. Because of the intervals we use. Remember, we use 10 meters, 20 meters. Yeah.
That's the standard.
20 meters, I think, is standard. Whenever, yeah. 20 meters actually is standard when you're going to do cross sections. And actually, there's situations where you even have to do 5 meters. When you're in curves and even junctions, you can do 5. You see, here it can look hard, but they tell you to implement on ground, and you have stations that are more than 20 meters. You're going to have errors. You get it? So even when the surveyors are putting points, you will even, if you are the engineer, you even tell them put 5 meters. Unless if the section is really straight, you can put maybe like 20. But now also if you put 20, it's also the grid operator has to balance these materials as they are doing as they are working. Well, if the grid operator, you give him maybe like 50 meters, are you sure that by the time you drive 50 meters, you'll be still with the level? Yeah, so you need to strike a balance with these things. So I think 20 meters is sufficient. Yeah, it has even gone off. You see, it has gone off the pipe. I think it's okay. So after having our sample line, now the next part is to do our cross sections. So I'm going to come to section views. I'll click on create multiple section views. Now that's where I can select the alignment where I'm going to do my sample line, my sample line group. Automatically it's getting from the start up to the end of the road. Then that's the view names, the section view names, the way they will be. This is the style it will have. You could come and check. You see, they have similar things like the way we saw the profiles. The annotation, the axes, and all that stuff. So I can go to the next. Now, here, you need to be very careful with the production. You need to make sure that the paper size that you choose here is having the same scale with your drawing scale. Otherwise, your things are either going to be very big or very small. So if you choose a paper size itself, this and your drawing scale is different, you won't have it messed up. So depending on whichever paper size that you choose. Let me choose this one.
What's the
A0. This is A0. A1. You can print it in that, then you scale it down maybe like A3 when you're printing. We choose A0. Now here, if you don't want it on the paper, you can come and draft them, place sections in a grid model. So sheets, you cannot grid them with this whatever option. Go together. So groups, how do you want to plot them? Here to give you some of the ways on how to. So by here, it's going to arrange them by rows. It will come from down toward this side. See, to ask you the start corner. So if you want it to start from down up, so there. So they will be like that. How do you want to align them via center line, left? You get it? Then the cell sizes, uniform for all, uniform per row. This really, and this is how how they will look like when you are setting them. Here you put the column width and then the row, the plot area, how you're going to plot the display. Really, that's it. Then you go to the next. It will get the swath width from the sample lines, put it here. But if you're not happy with this one, you can sample a wider area, but then you narrow down with the section views. So move the range, session range. I just leave it automatic. This is what it's going to sample. This is what I already sampled. So that's why it's really going to give me. So I'll just come and create section views. So I have to select where to place them. There are many. So I expect them to be there. Yeah. I look at this, I expect this to be 0, 0 because that's how I arrange them to start to be. This is the 0, 0. This is the existing road. You can see it. That is 20, 40, 60, blah, blah. And now you see these ones are those ones that have station, maybe there's a spray elevation change, the start of the curve. This, where you see this one. Now, if you had chosen absolute stations, it can get this thing, then keeps on adding 20. So you have all the values having these things. You get it? So to avoid that, just leave it as absolute. So if you want to add now more information, because we want now to see the design there. Now I need to sample. That's under sampling. So I need to come, click on the sample line. Okay. Then when I click on the sample line, they sample more sources. I click on sample more sources. For example, I want the corridor there. I just click on it, then I move it to the side. Okay. Let me also put the pipe. I click OK. When I do that, I expect it to have so when I go back, I should be able to see my cross sections. We're together. So you can see even the whatever I was telling you, the side cut stop ditch. These are the ones that after you design, how does it connect to the existing? How does it connect to the existing? This one too. This is the worker thing that we added there. All together. Let's see where we can see some pipes. You've seen them? I'm not seeing any. Which station? Hey, this one. I think because which chain is 80. Let me first split the viewports. $80. Let me check here. Is it a it is here. Yeah. Tax is on it. I think even 20 has it. Yeah. Yeah, there. So from here, if you have put your cross section, now you can adjust. Yeah, the drainage, since you can see it here now. And when you adjust, they keep on adjusting automatically. Let me try to adjust this one and see. For example, if I'm trying to bring it closer, let's see. See, this thing adjusted. This thing made. It's not off. I knew. This thing dropped down, like to the very bottom.
Oh.
Yeah, just remove it. The 0, 0. Let me just maybe bring it very close to this. You can see how it's moving. So if you want to put it below, I think below the whatever is somewhere here. Okay, it has not reached it. See? So you can adjust to the optimum size of this thing. Hope that's clear. Hmm? So let us try to compute some materials. Am I moving fast?
No? The progress.
Sure.
Okay.
So with this, I want to compute materials. Now, one of computing materials, let's say we are going to do, we want to establish how much we're going to cut and how much we're going to fill. The best way to do this is to get a surface. Remember, for computing materials, you need a surface. You need to compare two surfaces. You need to have a surface that is going to mimic the bottom of our structures. Not so. You need to get a surface that's going to go the bottom, then you compare that with our surface that we're going to use for EG. So to do that, we need to go back to the corridor. This corridor guy. Now under the corridor, you come to the corridor properties. Under the corridor properties, that's the dev corridor, that's the parameters. These are the codes that are there. The feature lines. Come to surfaces. There's no surfaces yet. I'll click on this tool, create a corridor surface. So it will also be called dev corridor. And just call it surface. This is style. We'll change the style. Let me have a 1 in 5 background. Then you need to put codes there. The codes we put are called datum codes. Now these codes are the ones that go below structures. They're called datum codes. It's very important. Here I want to have links, then you add them with that. Then make sure that they are there as break lines. Add break lines. Are we together? Then you come to boundaries to have a boundary for your whatever. So I'll just say corridor extent as an outer boundary. I just want it to be by the corridor extent. I don't want to go past the corridor extent. So patterns, those ones, I'm going to put them there. So I'll just say okay. When I say okay, it's going to compute and get for me a surface. So that surface, I think it's done. You won't see it here, but it will be this side. If I come to surfaces, I'll be able to see it, this one. If I select it and I take it to the object viewer, I should be able to see it. This one. You can see that it looks like the corridor, but it's just a surface that goes below. Right together. This is not a corridor. Yeah, it's a surface. Even when I try to let me show you. You see here, it's just a surface. It doesn't have any thickness. So then after, I can now, hey, you saw that by the I think I didn't show you. This is that surface didn't have this card drainage. So it doesn't have it because it was not coded. The datum surface, the datum codes. You get it? If you are to do that thing successfully to show up there, you need to code these codes. Now you have to come and put all these bottom codes and datum codes. You see that these codes have different colors. I don't know if you notice. They are coded, these ones. Do you notice that the datums have a different color? I think it's what, purple or what? They have that funny color. So all of them have that different whatever. So when I said use datum codes, it looked at all the datum codes, and then this one we are not coded, just ignore them. That's why sometimes you can do something and then just really you get headache as well, it's not working. So now the next thing is to add my surface here. If I click on that, sample more sources, I'll see a surface that is not sampled. I'll take it there. I might even remove the dev corridor. Let me first remove the dev corridor. You see these symbols? This is a symbol for a thin surface. This is a symbol for a corridor. This is a symbol for a corridor surface. You see that this symbol has a combination of this and this.
Yeah.
Huh?
Yeah.
He's not seeing it. This is a thin surface. This is a symbol for a corridor. Let me first see that it's going to pop up, that one.
Yeah.
Then this is for the corridor. Then this is a corridor surface. It combines them. So let me first remove that. I click OK. Automatically, my thing is going to go off. You see, it has gone off, and now I have a surface that is mimicking the bottom altogether. Then to have some small gaps like this, but these ones you can ignore them. Won't change that much. So let us come to sample more sources and we put back our corridor. Nice. So okay. Go back. Then now we are ready to start computing our materials. You need to have two surfaces. Okay. So where do you think we go to compute materials for this? There are two methods. One, I could come to the Analyze tab. Even when you click on this, one of the sample lines, is this thing of computing material. We're together. Even when if I go to the sampling properties, under sections, we'll show you the station. Actually, no, but I think it's okay. They hadn't shown, but it's okay. So I could come here to compute materials. You see that cut track with the calculator behind? The same cut track that is also here. This compute volume, compute material. It's the same. So I could come to that one. So it's asking me select an alignment. That's the alignment. This is the sample line. So I have two things here. Why I named the IGGI surface is because even the software name calls it IGGI surface. The existing ground. So here you need to select your EG surface. Here you select whatever is calling data has to be your corridor surface. All together. So what are you trying to compute? You're doing cuts and fill. Though you can do earthworks and materials list. All together. So you could say, okay. When you compute, nothing happens, but it has actually computed it. I just simply generate a report. And if you can see here, because whatever you see in green, see that in green, that's the fill, the red is the cut. Still processing. So now let us generate a volume report. That's the materials list one that we have. Then you click OK. Then you have a report that looks like this. Each station, that's the cut area, that's the volume, going all the way. So here, I think the net is what? The net is cut. You have to cut.
Okay.
Yeah. So fill, that's fill volume, cut volume. Wait. 20. This is how much you have to cut. Reusable. Because normally what it's assuming that whatever you're going to cut, you can reuse it somewhere to fill. So this is how much you have to cut. This is how much you have. It's cut and then it's reusable. Then whatever you have to fill is this. Then you have the fill volume. Okay. Then here you have cut as 0, because I think here you have a lot of fill. This negative is filling. Then keeps on persistation to give you the details of what, and then you have the cumulative. You see this tube? That's as you go along. You go up to the end of the project. Are we together? And you could even do other things like, for example, if you compute materials, whatever you're going to compute, you have already some materials there. Could edit it, but it's okay. Add new material. Cut material. Let's delete this from here. You could get a data type, not from a surface, maybe like from the corridor shape, what do you want to compute for? Let me say I want to compute for the sub-base material I will use. Then can add it. The different material. Why is it jamming to add it there? No, it's jamming to add it there. These clocked things, man. But you need to come and select the material that you're going to use. Now, this base is already named in the sub-assembly. It knows what is the base and what is that, and then it will just drive it through. Otherwise, jamming. add it there. First, use this one and see for it to get it for the shape. Okay, the base, jamming. Just too jamming. I don't know why. It's just freezing. That's where you go. Any question? Now we move to the export.
What's the address?
Hmm?
Yeah, I can write.
Sorry?
I just want to be using so we need the parents to.
You need to have interference. Like, for example, if you have many things that you want to analyze, what is interfering with the whatever? There are things, for example, I think that normally happens with networks. Like if you have a network of drawings, most times if you also have like multiple alignments, multiple corridors, there are things that can be. This that you have a junction in your. I'm not covering junction in this class, but if you're covering, if you have two alignments, you may find that maybe there's some interferences. Either the levels at the junction are not matching, like it will highlight some of those things. Visibility, that's when you driving. There's a tool called the vehicle tracking. It's a very good tool. It doesn't come by default with the software. I don't think you have it. Do you have it?
Which one?
The vehicle tracking, this one. You don't have it. Like you could even do a lot of stuff like you can try to mimic or maybe simulate a car, how it's going to move to a road. This one, it's something I think that you should get and download. It's a plugin. It's called vehicle tracking. Can help you design roundabouts. Adding roundabouts is not, maybe I can just hint on it. I don't know. Then I have to have two alignments. It's going to disturb my things. Anyway, let me just do it. I'll just remove it. Let's have this alignment. I have this one. Try continue first. Save. So this alignment. Then I have this one. I'll just hint on it. Then you have two alignments. So I'll come to alignment from objects. I have this one. I'll just have it that way. I'll call it maybe. Let me just call it alignment 1. Then I have this one. For objects, click on that. It's going to be alignment 2. There are two alignments. So now I come to intersections. Okay. Under intersections, there is that tool for the roundabout. You can also find it at the vehicle tracking, but I don't think you guys have it. It's a plugin you can add in. Let me see if I downloaded it. I could just share it with you guys. 03 2025. Yeah. Is this package here? Do you have a flash? Let me first send code record tracking. Just but you need to install it when you close the software.
When you close the software.
Yeah, then you open it. So here also here I have the option of adding a roundabout, but let's go back to the side. I'll come add create a roundabout because for it's a whole different sort of thing. You have for intersection normally you have approaches and exits. We have the main approach. Main approach that's the main road for the increasing chainage. Then you have the main exit. Then you also have other whatever. Just create a roundabout. So it asks me the name of the roundabout. Now these parameters, you get them again. These parameters are specified in the design manual. The inscribed diameters, the island diameter, the island in the middle of the roundabout. The diameter, I'll just leave this by default. Then click OK. Here it's asking me where do you want to put the roundabout. I would put it right here. So it's asking me, select the line defining the new axis, the center line. So I could maybe have that, having that, those parameters, having depending on how you're designing the roundabout. So you have these things, but already you need to have your offset alignments right together. You need to have your offset alignments. Then you come and put other parameters throughout your roundabout. Sorry? Then you can also have a normal intersection. You see, this create roundabout, create intersection. It's also part. All together. Then under vehicle tracking, you can see. Let's see if I can let's edit drive. Thing. Overloading this computer. Well, my computer instead. Eh? A lot of things running. This is why I had to first save my work. Just post close it. Even me ending the task is jamming. Hey, not old. Hey, my data has disappeared. With our drawing. It's like our drawing has gone along. I think it's this one. Okay, so this is where we want. So I want now to print out this work. Okay, it's not that you're just going to get this thing and just put it on a paper. It's going to go through the standard whatever. Though as you're printing out, you may have to first deactivate some layers. For example, if you're printing out this, you may first maybe have alignments, then you have an alignment drawing. You get it? Otherwise, if you put them all together in one drawing, it's just going to be crowded. But I'll just show you the method. You can just use it on other things. So export anything. We come to because these ones are already like in the format of exporting. So this is quite easy. I want to show you for the alignment. We have first create what we call the view frame. Then after creating the view frames, then you can create sheets. Then I'm going to first come and create a view frame group. The first one, we select the alignment, which alignment we are going to use. The next, what do you want to plot? Are you going to plot plan and profile at the same time, or you want plans only? Here it will show you, or profiles only, depends. Then just do plan and profile. It gives me a plan and the profile view for that plan. You get it? Then here you have how do you want them to be placed along the alignment or rotate to the north, or them be rotated to the north. Depends on what you want. And just have them along the alignment. Then you can have set the first view frame before the start of the alignment by that. What that means that if your alignment is starting here, your view frame should have an offset altogether. Otherwise, if you don't want it to have that offset, you make it 0. Yeah, put an offset of 10. You can change that. The next, that's the name of the view frame group and all the stuff. Just next. Then create view frames. You have the view frames in that line. Then you have what we call the match lines. These are match lines. Match line is a line that will appear, or it will demarcate the whatever from this side to this side. Yeah. As we're putting the things. So here you can see that it has put the match line number, the station where it is, then the previous sheet number. Now we don't have sheets yet. That's why it's putting the hash. All that. After creating the view frame groups, now we come to create sheets. Not section sheets. Section sheets are ready. The other one that we've seen the other side. So I want to create sheets. Now to create sheets, you need to already have a view frame group. Yeah. So you have here the view frame group. That's the main alignment. The number of layouts per drawing. Now this is very important. If you leave it at this, it will create new drawings for each layout. Then this one puts all of them in the new drawing. To just create a new drawing and put all those layouts there. Then there's this one, putting all layouts in the current drawing. So it will put all the layouts in just this drawing. Let me just use this. So that's the layout name. It will be the sheet, then whatever. So if maybe I have the name of the project, I can put there. Just call it dev. But if you have maybe like Cotido, whatever, just put it there. Then choose the north arrow block in the layouts. So you can choose any block for the north arrow that you're going to put there. Then you go to the next. So that's the new sheet set. Go to the next. Now this is going to be the plan and profile view that you're going to use. So if I see here, you have the profile view, and that's the band based on the elevation that we have here. So here are the profile properties for the alignments. If you want to select, but that's the alignment that we want to choose. So now this is also another important aspect. How do you want to align the profile and the plan? Here to show you that it will align the start with the start. Here it will align the center with the center. Here it will align end with the end. So sometimes if you don't align, if they don't come out the way you want, at those points that I'm saying that an important part to note. Yeah. So I think that's it. Don't see any more things here to check. Just say create sheets. Yes, it's saying me that to complete this process, the current drawing will be saved. So just save it. So it's asking me, please select the profile view origin. Now I don't select in this one. It's going to create for me a profile view for the export. Just have to come and select somewhere. It will generate them. Yeah. So you can see it has shown me from where it starts. It has prioritized this thing. It has prioritized something I didn't want it to prioritize. I'd forgotten that setting. Anyway, if you look at this, you see and this is about the scale, just that the paper size I'm using is big. I'm using A0. A0 is like the biggest. That's why it's like they're appearing very small. So you can see here it has given you, but as I said, don't put them in the same whatever, have different exports. Then that section it has put for you, it's prioritizing this, the alignments, the profiles. It's not prioritizing the pipe network. That's why it has kind of broken it up. That's on the first one. Then the sheet 2. Still, it has looked at that. Up to that, if you want to edit anything to do with this, you come back to the model. Now that view is still looking this side. So if I say I edit this style, let me see which profile, whatever am I using here? The profile view properties. I'm using which one here? Profile view should be able to work for me. This one is what? Profile view properties. This is a profile view. Okay. Let's check the graphs, grid, clip. And why is it acting weird? Let me first use the land desktop. Don't access this one. We have already covered them. Just trying to look for if there's anything that I've missed out. The vertical exaggeration, I think that's okay. Yeah. I think the profiles are there. Bands, arches, pipe networks. I think that's it. You just keep on editing them from this side. So as you edit, they keep on showing this side. For the section sheets, because I'm not showing you how to do the section sheets. Since you already have this section sheet, there's no need for you to do the view frames. If you go to output, create section sheets, it already knows, it has already picked that you've already done the sheets. Just trying to check if there's anything I need to check here. Looks okay. Yes. Now these are the section sheets. I should come down here. You can see that it has plotted them. Some are missing. What paper size is it using? Sheet 1. It's using S0. Then why it has messed up these ones, the first ones. Yeah. Just be a glitch. And sometimes if you close the drawing and open it again, they get better. I don't know. This one, Jesus Christ, what is this? I think it's stupid. This one I have to adjust and put it back where it's supposed to be. Let me get. Now it has put there. Man, it's quite things I don't know. Now you see this one. Well, anyway, you get the point.
Yeah.
Maybe what I didn't show you how to edit these texts. Adding notes, those are easy. Actually, I think that's why I jumped them. Let me show you. But the drawing is getting heavier. It's disturbing this thing. So edit these things like the text, the boundary, the whatever. Sometimes they can be disturbing if you don't know where to go. If I click on this, it gets, yeah, remember that thing that we were editing from the profile view? It's almost similar. Now there's section views, and then there's a view group properties. This is editing them as a group to show you all of them. And you can change it, for example, the style at once. You get the road section style would come under the graph, grid, these are clipped title annotations. If maybe you want the title to be in a different font. Put time one. The size, if it's too big, let me put maybe like 2. Around axis, this axis. Here it's using the major interval at 10, then the minor at 5. Is it? Now I'm using this, it's using 10 instead. These ones. I can make this 5, but then there will be very many squares down there. Let me leave it at that. Then you come to this one on the side. These ones, these labels. You will have them. Times New Romans. The text size, text height is where? Here. Then put at 0.5. The minor will not be labeled that much. Display. It's okay, and yes. Yeah, something changed. Which one changed? I've seen these titles changing, and these labels this side. So that's the style. Let's get to one of these ones. For the horizontal, for these ones, I think the vertical axis, we only edit the right. the left. Let me just put one. But as you're editing, it also changes the other side of the other side of the sheets. Zero one, give it away. Hey, this is also 10 meters. Ah, 10 meters, too much. 0.5. Let's see how that works out. Yeah, it's better. Yeah, 10 meters. I hadn't seen that. Now this is there, whatever get big. On the at 0 point. That's the offsets. Is nothing much to change. If you want maybe to change it, those change, yes. Hmm? Okay. This should be okay. That's how you keep on changing them. Let's try to get this on a closer loop. Going is heavy. Hmm? Plus, as I'm working, it keeps so yeah? The sheets, eh? Yeah, but now it's getting heavier and heavier. Actually, I should have put them in a new drawing. Should have created and put them in a new drawing. I think it should have been better. Yeah, I think this is now better to visualize from here. So go to the data management. Here. Hope it doesn't mess me up again. They have even disappeared. They're here. These ones or these ones? The one for the sections or the ones for the output? Okay. No problem. They're getting smaller. Yeah, you can add the legend, can add the north arrow. That's why I was like, I think that's kind of the north arrow. You can put the scale bar. I think let me use this. Sorry. Can add a legend, you can put a reference system. It's more like grid. And these are the grids. It has made them like that because of the north arrow. You see that north arrow, the way it's moving. You get it? These things are really just come and add a legend. Yes, it's just disturbing. It's just heavy. When you're working, Someone also if you want to test someone's patience, give them a computer that has either it is slow or it has slow internet.
Now, like in this one of design, they give you, now you say you have a very good machine that has, you can cover machine that's not lagging at all. You can talk to like 3,000.
Which are lacking.
Can
be like
because we used to do already, speed stars, speed, come. That's why
quick it fast things.
the thing was telling you this, now, for instance, let's use the desktop.
The desktops have better cooling.
Around and one year,
But there are some good laptops, there are some business. You can compare. You can compare. The thing is just jamming. I don't even know if it's going to recover. But anyway, you still have to go to get this thing. If in case I don't, it's going to disturb me and just leave it. If I do my data management before it finishes. It crashed and I've not finished the content. So normally when you have multiple drawings, just like the way we can split this drawing, you want to copy certain things from here to be used in another drawing. That way we call it data management. You can copy things like surfaces, alignments, whatever. And there's two space. When I come down here, under Prospector tab, we have the Data Shortcuts tab. And if I come to here, I'll find it under Manage. So one, you need first select the working folder. Set a working folder that you're going to use for your whatever that you're going to use. So here I'm going to call it, let me just call it May batch. And let me first show you something. If I go to that folder, this one, it's empty by now. I select this one, I say select folder. I check it, still empty. Okay? But these things are so many. Let me just close them. Maybe the ones even arguing my computer down. This is I think, yes. Yeah. So after setting this, let's set the project folder. You could come and set that one, but you have not yet gotten there yet. You can find the similar options also this side when you come and right click on this thing, which looks like a database. What we had done was set a working folder. Okay, so you can now come and create. Why is it jamming? Sorry. I suppose first create a new data shortcut folder, which is different from this one. Yeah, the other one was just a working folder. This is different. So you need to come and set a new data shortcuts project folder, which I will come, call it maybe my batch. Let me call it what? Final session. Okay? Just to distinguish it from the other one I created. So then I'll say, okay, when I come here, it has put it there. And when I open it, it has already some files. folders automatically created. For example, alignments, corridors, pipe. Now, these are things that you can have shortcuts for. Are we together? Then, now it has put it in the brackets here. You can see it. I mean that I'm ready to start creating my data shortcuts. And right click, then I come. They ask me, what do you want to create shortcuts for? I can say the surfaces I have, alignments, sample line, then just select everything. Pipe networks, view frame groups. Then I say, okay. Now these things come here as shortcuts. Okay? If by any chance, let me save this. I open another drawing. I don't want to go through the hassle of creating the whatevers. This is the new drawing. And just set the coordinate system and start working. Now, if I want to bring in a surface, I can just come to one of my surfaces. Now, I need to make sure that all these two drawings are looking in the same project folder. If it's not, then I come and set the same correct working folder this side. But since I've opened them concurrently, it's already like aware that I'm using the same project folder. So I come, click on that. Now that's the surface. When I right click, there are two ways. There is create a reference or promote. Create a reference references the surface from their drawing. It does not, it can use it, but cannot edit it. You get it? For example, if I create a reference, I do that, then I zoom in where it is. I have a surface from the other side. But this surface, if I click on it, if I click on it, there's nothing like edit surface. It's just synchronize. Synchronize means that it has created a reference, but this is the mother drawing. So it holds the capability of editing it. If I click on this one, there's edit surface. The other side, it's not there. Okay, then. So here, if I click on this, it really synchronize open source. And I can use it to do other analysis. If I want it to also be able to edit here, I promote. You get? I right click, there's promote. And when I promote and I click, now I can edit the surface. So when you're a designer and get a drawing from the surveyor, I highly suggest that you don't open your drawing. You don't start from scratch creating your surface. Open their drawing, create data shortcuts, promote that surface that they have given you. And do not work in their drawing. Because if you work in their drawing and there are mistakes, I mean, can be a little bit challenging for you. Figure out whether it's your mistake or for the survey team. Together. Yeah, so this surface comes with all the break lines, with everything. Here, if I want to edit anything else, to import anything else, I can bring in. See that cut symbol for a shortcut? Yeah, it's there. So the main alignment, I can right click, create a reference. It's just like the same things, it will come to have all the edits and all that stuff, but the things I cannot do, I cannot edit.
Just found because
If you are, because
work.
if you're going to do work, you can if it's not your alignment and there's no need for you to edit it, you can just reference it. Unless if you really have to edit, then you can edit it. Pipe network still the same. Can just come reference. As here, you can even have different surfaces for this. And have it here. That marks the end of the course. Seem to have a question. We have an assignment. I think, did I share it with you? Remember, I shared a folder that had assignments.
How do you create services using KML files?
You have a KML file.
No, I don't have to see. For instance, if someone sends you KML file from the file, you could set it.
It has to have either contours. It has to have 3D objects in it. You get it? If you had one, we would try it. Normally, they get them from Google Earth. Sometimes. Yeah.
I think it can also give you
Yeah, they can actually also give you those things. But now, normally, from the KML, you might you might first go through the process of ArcGIS because can do it better for you. But if you have one here, we can give it. You have one? Yeah.
it's a KML.
KMZ and KML, they're almost the same whatever. It's up there. Let me check it. I remember. So 3D. What's this now? Okay, let me first get the whatever for. Because I remember shared it with who? Assignment.
About to
Hmm?
sing out a pipe structure.
What do you mean?
As in, if someone can very creative, stone order structure. How about generating a, for instance, in the question carvers, how would you create those structures?
Hey, those canvas, you put structure, then you connect with the pipe that you want.
In
Mm.
there is a drawing
Mm.
that has details.
Hey, you mean how to generate the digital drawing? I don't know if I've gotten what you're saying, but I need first to close this drawing because it's going to mess up. Let me first close it, otherwise. Is this whatever? Let's check if you can access this. Let's check if you can access that whatever. That file. You're saying, let me see if I have some drainage. Let me stop the recording because, hey, should I stop it or I continue recording? And I think let me record because it may be helpful. The meaning something like this. Something like this.
Yes.
This you have to get from so I had done a lot of things with it. I have a clean one. Okay, let's say the clean one. Something like this. Now these are details. The other one we are doing the generic design. You need to have the detailed drawing with this. This one you can scale it and just have these things drawn. You get it? I don't know if I'm clear.
And so that's wonderful.
You guy, you're taking me back to that drawing. Okay, let me first share these things. You have seen the whatever?
Yeah.
It's it's opening, eh? Let me first the passwords thing, leave it out. Mm. So it's like this. I've shared with you a drawing. This one, it's you'll find the thing is it's in an imperial system. Eh? This is the drawing. It's in there. It's called Yosemite. It's from our headquarters. It's like a standard assignment they give Osmo 3D. So that's why you find that it's not in our system. It's a metric system. It's not rather it's not in the metric system. It's a imperial. This is it. You get it in form of contours. It's already the surface. Listen. Just an interesting surface like this. So that surface, what do they require you to do? They're requiring you to use that drawing to design a new graded area for construction of a new park, design the roadway access to the new resort, and lay the utilities to provide a sewer potable water. Utilize minimum fissure lines, grading groups, criteria, alignment profiles, assemblies, corridors, pipe networks, and pressure networks. You can leave out the pressure networks. Then the way we are going to score it, do you have the grading created? Do you have the access roadway created? Do you have a good sewer network? So for that, is it hard? 2 weeks. Yeah, but it's not hard. I feel like we've covered more than what is even needed here.
So it's U160.
Let's check. No. Yeah. B13th, yes. But the faster you submit, the faster the certificate comes out. Yeah.
Great.
If you submit even tomorrow,
Great.
I grade.
You're the one.
I grade that and also
this.
I forward.
You said this.
It's there in the folder I shared.
No.
It's not there.
There is another one.
Are you sure? Don't tell me you have an old one there. Aye. Huh? What? Wait.
Let's share it.
It's a different one. I think I've shared a different one. Let me check. Hey, wait. What you have is old.
That's why I was asking why password WhatsApp is the password.
Training data. Hey. We are going to cheat. That one is easy.
No, that's
Yeah. Let me be.
That's why.
I was going to blunder with that. Hey, let me even create another folder here. For 3D. That's an old one. We stopped using that one in 2021, I guess. It was so easy. Did I miss that? So there's this new one I want to share. Hey. Cancel uploads. Yeah. Thanks for reminding me. I'd forgotten that one now. I was going to just continue. Those students who didn't do the work, then the teacher has forgotten about the assignment. Then they say like, last time you gave us an assignment and you didn't do the work, and get like, okay, open your books. You first cross check this one, that one that I've put now. This is the drawing. Cross check if the drawing can open.
In Imperial.
Yeah, it's in Imperial. You find that the things are in Imperial.
So we have to create in Imperial.
Yeah.
Nothing changed. Steps are always just different.
Yeah. Or you could even first change it to metric, then you work, then you change it back to Imperial.
If I work in Imperial, nothing doesn't affect.
Yeah, it doesn't affect it.
Let's choose my opinion.
And you need to identify.
And see that this is
Perfect. It's like a client comes to you and like, I want to construct something here, but what do you suggest?
just the usability of EWP is just it's just the surface.
Yeah,
But even the road
it's you to plan them.
so
But it's interesting. It's nice, I guess.
it's a red
Hmm?
everything is red. It's friendly. Yeah. Once you do something, you can't stand on it. And yours, dude, that's what I was thinking. That's how to you only police. English was going and now put most of the time for voices.
Now it goes back to if you have what you've learned.
Yeah, so it is a reload, you can still do the same thing.
I don't know.
We are proving it. Oh, this is a copy.
I don't know. So you wanted to see how to import the K whatever.
I said
So I downloaded it. It is here. It's this one, right? Let me see. But I'm more than sure that what I've given you is really more than enough to even accomplish that assignment. So let me first see if this thing opens here. You checking that it opens, eh?
This one, if you're saying
No, this.
that one,
Yeah.
it's opening.
Okay. Perfect. You know the coordinate system? I think it's using WGS84 or ARC.
Actually, it's new week that
Yeah. You beat it in ARC. You're on the airport.
yeah, I was there.
Yeah, the guys want to make our planes crash. Yeah. Then we walked there and crossing a walkway. This line, the runway. You have to ask permission. The guy at the tower, you have to ask the tower. They give you radio channels and you have to like you tell the guy in the tower, you ask for permission to cross. Then he says negative, don't. Even to pick something on the runway, you have to first ask for tower permission. So to import those things, the KMZ, whatever, if you want to do more analysis before you import it in, because if you import it in, really, it's almost hard to edit more. But after doing the analysis, and then you sure that your KMZ is okay. Because if it's not, now like the way I've seen this one, you are picking road whatever's, right? So if you want maybe center line, what, blah, 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 you could first do some analysis and make sure it's okay. And if not, you do whatever. But then after, you come to import, this import map. I think it's map import, something like that. I think it's map import, this one. You navigate where you saved your table. Make sure that here in the files you're using the KML or KMZ. You click on it, that's it. To show you what's going to import, no coordinate system assigned to the current drawing. So you have to set a coordinate system after. You get it? That's what I was asking, which coordinate system we used. I don't know which coordinate system we used. No extents. So the points are here. If you click on one, you can see that these are points. But if you see that they don't have descriptions, you get it? But they have the Z. Ha! That's even placed them in a bad way, or very weird way, placing them. Do you see the positions? To maintain the whatever. So another way I would suggest, before you bring them this side, use ArcGIS or QGIS, kind of align them well. And actually, also, maybe also, maybe mention this, that sometimes when you get a drawing, like just having contours, sometimes someone explodes the contours and then they give you to work with. Yes, Christ. In the catalog, folders and connections. is the main batch. It is this one. This is it. So ArcGIS will open it for you. It should be whatever. And if I check in the properties, I think I should be able to see the coordinate system that is being used. It's using WS84. And I think if I check in the attribute table, I need to export this layer. I think you don't have attributes. You really don't have attributes. Check the metadata. Okay. Let's get in the data processing. Okay, it's a KML, eh? KMZ. We'll do conversion. Map to KMZ. KMZ to layer. KMZ file. This one. Location. Yep. Just run that. They're here. It's having them like this. This is weird. Okay. It's okay. Let me get to this point. So, so I'm going to export it from this format to CAD, AutoCAD. Just get these output drawing files. Yeah. This is the file. I've put it in ArcGIS, then I exported it to CAD. I want to see how it's going to look like here. Continue opening. Eh, that's the mean. But still, if you look at the whatever,
This one.
messes them up. Let me first create a surface from this side. Let me first create a surface. IDW or Topot raster. Point features. Yeah. Somehow it disappears the Z's from here. It disappears the Z's. Something that you have to like investigate further.